Hello, everyone. Good morning or good afternoon, depending on where you are connecting from. I am Carlos Marquez. I'll be your moderator today, and I'd like to welcome you to this webinar, High Performance PV Rooftops for the Middle East and Africa. So today we'll have three experts from Trina Solar, Sungrow, and Eversheds talk about different aspects of PV, rooftop PV, and well, I know you've just seen it on the video now, but I'd like to encourage you to go to the chat function and present yourself and say where you are connecting from. I am actually connecting from Berlin today, so sunny Berlin. In any case, I'll let the speakers introduce themselves briefly. I'm going to stop sharing my screen now, so you can see them. And right, so Ewan, would you like to start presenting yourself very briefly?
Hi, I'd be delighted to. Yeah, my name's Ewan Walters. I'm a partner with Eversheds Sutherland. I'm based in Dubai. I focus on clean energy projects in the region. Before I moved to this region, I was focusing on clean energy projects in Europe. I work at Eversheds Sutherland, who are an international law firm, one of the largest globally. We have offices throughout the world, in North America, in Europe, in Asia, and in this region, we are in Qatar, Iraq, UAE, Saudi, and I think that's it. That's a brief introduction. So I'm here to cover all the legal questions and aspects of rooftop solar.
Thank you very much, Ewan. And next, Shield Shi, if you can introduce yourself briefly, please.
Okay, thank you, Carlos. This is Shield Shi from Sungrow headquarters. I'm based in Hefei, China, and I'm dedicated for the channel support for our inverter products and accessories. Nice to meet you all.
Nice to meet you too, Shield. And then Dia, if you could introduce yourself and then get ready to share your screen because you'll be the first one to present.
Hello everybody, my name is Dia Eid. I'm the regional manager for Trina Solar, Middle East and Africa, and I'm responsible for the sales around the region. And thank you, Carlos, and thanks for everybody's given time today and to attend. And I will start shortly to share my screen, then we can start our webinar.
Great, thank you very much, Dia. So whilst you are sharing your screen, I would like to remind everyone that this is your chance to ask questions. So for those of you who are new to our webinars, if you go to the bottom of the screen, there is a Q&A function and you can send your questions there. Without further ado, please, Dia, if you can start your presentation.
Hello everybody. Thanks for attending today, and thanks for making time for us to give a brief about our latest technology and innovation, Vertex S. Mainly for this topic, it will be different from my previous webinars, as we were always talking about the ultra power modules, which is using for a bigger CNI project and utility. So to complete our product portfolio, to make sure that everybody's aware of what's going on in our innovative technology. So today I'm gonna speak different, and we will be speaking about rooftops and residential mainly. So this is gonna be a small and brief one, and as Carlos mentioned, that's feel free to ask anything in the mid of the session, so we will be happy to clarify and answer everything. I will start with a small intro about Trina and about our Vertex S and our new technology of the 210 mm cells. Then I will talk about the technical overview about the cell itself and about the module. So then we will move for the system compatibility, which is the most hot topic right now, especially for the new integrated cell with the 210. Then we will talk about the added value, which using a Vertex S for your projects can bring and how it will impact your levelized cost of energy and POS saving. So this is a small video about our factory. So I will be happy if you can see it, then we can start directly. I will just start for a small brief about Trina. Trina founded in 1997, and since then we started to the solar business industry, and we started to be specialized in the PV module supply. So talking about the main concern about everybody knows the tier 1 companies. Trina is one of the top tier 1 companies. And for the bankability, we are comes in 5 times in a row from 2016 to 2020 as per Bloomberg and EF. So as you know, that's every year some companies jump in and jump down again. But our main and our aim just to keep always in the leadership. So just to keep the sustainability of our bankability. From the leading technology and innovation, as you can see today, that we are, or from the previous supplies when Trina was introduced into the market, Trina is always coming with a different perspective for the traditional or conventional solar panel existed in the market. So we were happy to introduce our 210 cells to the market as a first supplier to finish the R&D and to launch the product to the market. So from the history, we have a 20 world record in innovation, and we have more than 852 patents for our product. So when we are talking about providing top quality products, that we are talking about the global standards, all of our module company, all of our module series is receiving a UL and getting the test data program certifications. Our warranty, for the product warranty, we have a 10 to 12 based on your product. For the performance warranty and power warranty, it's from 25 to 30 based on the product as well. For testing, we are performing more than 200 tests in our factories, which you had seen now in the video. So for reliability, that's our all products having a certain quality certificate. I don't think that someone would have been experienced with Trina before that's had a lack of getting a certification or getting the modules to be supplied. So we have a global presence, which we are having our module in more than 100 countries. We have a 50 gigawatt module supplied, and we have 3 gigawatt connected to the grid, and we are more than 12,000, which shown in red here is our subsidiary office. Then the office which I'm based from is a Middle East and Africa office, which is based in Dubai. So the integration of innovation about the cell itself, then we know that the cell, when you are just going to get the higher efficiency cell or you get the highest technology in the cell, it's actually impact the module itself because it gives the total efficiency and the total reliability for the module you are providing. So for our 210 cell, that we are talking about the largest wafer exists in the market today, that we actually jumped from the M10 to M12 directly. We didn't be through it, which is the 182 mm. So we jumped with the 210. So we are introducing the market now one step ahead of the innovative wafers which exist today. The second thing is the multiple bus bar. We know that the bus bar rounds is when we make the round draper, which is getting a better light trapping effect, and the stronger current collection can be with the low series resistance existing. Then we come to the point of the cutting. Trina is actually accommodating an NDC, which is the non-destructive cutting, which is really gives the high efficiency of each cell that you can have it, which when you do the cutting, either you will do the third cut or you will do the half cut, which makes sure that actually the cell which we are receiving, that it's mostly the same conventional cell exists in a full cell. So it didn't impact the efficiency, it didn't have the risk of micro crack. The high density interaction, it's the technology which is Trina coming for doing different interaction between the cell. Then I will show it in the next graph. So this is here when I was talking about the NDC. So as we can say that the mechanical separation, which is the conventional mechanical separation on the high temperature, more than 1500 Celsius degree, that it makes like a tough surface and it makes it rough, and the micro cracks ability is going to be very high. So using a low temperature and non-destructive cutting, so it gives the smooth surface, and which means there is no crack in the cell itself. So going there and to see the difference between the full cell and the non-destructive cut itself, that we find it's almost from the mechanical perspective between the full cell and non-destructive cell. This is the conventional cell, which had been normally cutting on the mechanical separation. The second thing I was already highlighting in the slide before the last one, the high density interaction. So most of the companies right now is using the shingling or overlapping between them, which increase the micro cracks and overlap area. But for Trina, we are accommodating the high density, which is giving a gap between the two cells themselves, which is like 0.5 mm. So it makes the module is having a higher efficiency and less in micro cracking. So right now, just moving from talking in general about the cell and about the modules itself, let's get to talk specifically about what we are going to talk today. So as we can see the global increase for the installation forecast in gigawatts, so we can see the utility businesses growing as well as the non-utility businesses growing. All of us as a tier one company, we are just competing with each other on getting higher modules, ultra towers, higher efficiency, bigger modules. So everybody is going high to the level that the non-utility business, not everybody is covering in the same unique way which we are covering the utility scale or the big CNI. But for us in Trina, that we are always considering the complete portfolio is one of the successful points. That's why we decided for this fast growing market, which is non-utility, is a big market as well comparing to the utility in the next 5 years. We designed a product which it can satisfy the market and it be as well a landmark or a trademark for the CNI and rooftop business. So talking about the non-utility business, we are talking about residential and rooftops as well. So if you consider what's the requirements, what the curriculum non-utility business system needs to be a really very efficient system, and it will be achieving all your needs and at the same time satisfying the all parties which is involved in the cycle, from the EPC, from the end user, from the owner of the place itself, and from the installer. So you need to get the higher power, you need to get the best efficiency, the compatible sites, which helps you to make sure that you are using every single part of the area you are covering in your pitch. Then the weight of the module itself, which is easier life for doing the installation, handlation, and moving stuff from a place to place. Reliability to get a product which really you can put it in your rooftop or in your residential and make sure that you will forget it forever. Then the last, as long as this is a rooftops and it's in a residential area, we cannot really neglect the appearance, which is exists like from a module to module. Then choosing a module with a good looking or with a good appearance is a really critical point, especially it's your home. You are paying a lot of money to do the exteriors, to do the design of the home itself, or to the building or the office you have. So it doesn't mean that you will just get something industrial, you will put it in the top, and at the end you will find it's given really an ugly base. So for all of these reasons, Trina tried to combine all of the requirements which the non-utility business can get it, and we introduced our Vertex S to the market. So our Vertex S belongs to our Vertex family, which is at the same time all our Vertex family. When we talk a Vertex in Trina, we are talking about the 210 mm modules. So talking about this module, then we are talking about Vertex S is the smaller, like the smaller son in the Vertex family, which is from the size perspective, it's around 1.75 meter multiplied by 1.1 meter. For the weight, it's almost 21 kg. Temperature coefficient is around -0.03% per Celsius degree. And the degradation is 2% in the first year. The annual degradation from the second year to the 25 years, it's 0.55%. The power warranty for this product or the performance warranty is 25 years. The product workmanship, it's 12 years. So we are talking right now about efficiency, which is 2.1%. So as I speak before about the characteristic, the 210 bigger wafers, advanced multiple bus bar, creative non-destructive cutting, which I had explained before. The layouts comes here 5x8. So it's 5x8 layout with a third cut cell. So we are talking about small in size and bigger in power. So comparing Vertex S on what exists in the market today from the same family or from the same range of the product, we are talking about 60 watt extra. So Vertex S, which when we are saying big on power, because comparing to the same size of the module, either from 158 mm cells or from 166 cells, that we will find that on the same power you are getting around 60 watt extra than the as per watt per meter square when you are comparing it on the same module. So when we talk as well for the small form factor, that we can see that as per the weight and as per the length, it's very small. That's which you can easily carry on, and you can just use a single person to carry the module and start the installation. So which gives you the easy time for deployment, and it gives less in the logistics, and you will get it in a better way for your project. So this comparison had been done from the same module, which are in the same family, but from the different technology of the cell. I mean the smaller cell, either the 158 or 166 or 82 modules. So how this can pose to the rooftop photovoltaic system, which makes your power yield up to 10 to 23%. Actually, we had implemented a simulation on the same rooftop, which we can say this is a south face rooftop in China. As we can see, the same dimension, 16.7, 9.6, from the other perspective, 5.3. So we started to deploy the same module from a different serial for the different cells. So when we started to use the 158, the 405, which is exist for some of the competition, and 158, the 60 as well, which is the 340, 166, which is the 370 watt. And at the end, we will find that this is how many pieces you are installing on the roof service, which is the south service you are doing the installation. This is using the 158 405, the old one, the conventional one. This is using the 158, the 60 cell, which is 340. And this is using 166 cell, I mean the cell size, 370. So you're using here 32 pieces, 48 pieces, 45 pieces. Uses the Vertex S, which is the 210, 405. So use a 45 pieces, 3 row by 15. So you achieve even higher power from the DC side. And for the total yield on over 25 years, that will be the difference of using other modules than using a Vertex S. Now we are talking about the system compatibility. So when we talk about the system compatibility, we are talking about the mounting solution and the inverter selection. So talking about the universal solution for residential and CNI rooftops. So we will start with the mounting structure. The diversity of the installation, which makes the flexible for the system deployment, we can see that that's all of our Vertex S modules can be compatible with all the kind of installation, either 4 points mounting, points of mounting in Japan, the sharing rail for the global sharing, which can be used worldwide, the cross beam, which is as well as a global installation, the side mounting in Europe, with a positive load of 5,000 Pascal maximum, and the negative load is 4,000 Pascal minimum. So for the inverter, I will just give the chance now to my colleague, Child, and he will speak about the inverter better than I do, because he will talk purely about the inverter. But what I wanted just to guarantee that all the inverters can be compatible with our Vertex S. So our short circuits are 12.34, the VOC is 41.4. So comparing to the 166 cell, so on the 37 watt, the I short circuit is 11.3 and VOC. So we are getting extra 60 from 30 to 60 watt on the same current and the same voltage. So now I will talk about durability and the reliability of the system. So we are talking about very low degradation and high power yield with a longer warranty. So this is which we explained as well in the previous slides, that the Vertex S comes in 2% of degradation in the first year and 0.55% degradation from the second year to the 25 years. Comparing this one with the same degradation on the same series of 158 or 166 is really totally different. I need to confirm again of the workshop that's the warranty starts from 10 to 12 years, and on the power performance from 25 to 30 years. So making things more elite or more iconic, that's some people, they really go for luxurious or elite models. So we made another range of the Vertex S module, which is fully black. It's a really black, thinner in wire that appears all black in a distance. Excellent cell color control by dedicated cell planking treatments. So as you can see that the module is really looks nice. So the added value, as we are explained now from the yield perspective, from the VOC, from the minimization of the installation using the Vertex S, I'm just gonna move to the logistics and the green economy on the biggest part. So when we are talking about the added value here, we can put it in the two ways. In the first way, the prices which you get for the logistic, and second one is the lower carbon footprint. As we are comparing as well Vertex S with the 158 and 166 cell, that we will find it's per container, Vertex S is having the highest capacity you can add it in one container. So if 158, it's having 265 cell, sorry, 265 kilowatt, 166 having 289 kilowatt. Our Vertex S per container is how 379 kilowatt in one container. So in the domestic and the simulation for the semi-trail track, you can even put 408 kilowatt per track. So this is the capacity plan of a Vertex S. We have a mass production started in last January. Then we have a 5 giga for this year, 10 mega for the next year, and 15 giga for the year after. This is the series of a Vertex family. So we have the small child, which is Vertex S, the 405. Then we come for the CNI business as well. We are using our 500 Vertex. Then 550 for bigger CNI, and for utility, 600 up to 660. So then we will talk about the conclusion of the Vertex S. We are talking about the wattage of 405 and 21.1 efficiency. The module can give you 60 watt comparing to the same modules in the same. The generation pulses from 10% to 20% plus. It's easy for deployment, as I explained on the South Service top, the example which we said on the size for the small form factor. It's a low degradation, longer warranty, and higher power unit. And the new one, which is having the black for a green. Thank you, everybody, and thanks for giving me time. So I will give it to Carlos.
Thank you, Dia, for your presentation. Very interesting, and well, whilst you stop sharing your screen and Shield gets ready to present, I'd like to encourage everyone to send questions through the Q&A box. It's your chance to have your questions answered by people who actually know about rooftop PV today. So it's a unique chance. So Shield, how are you doing there with sharing the screen?
Okay, got it.
Yeah. Right, over to you, Shield.
Okay. Can you see the screen now?
Yeah, I can see it perfectly, yes.
Okay, thank you for ATA, and thank you for China Solar. Here's Shi from Sangro headquarters, and today I'm going to have a short presentation about our distribution solution for Mina Solar. First of all, it's a small introduction for Sangro. Sangro was founded by university professor Cao Renxian in the same year with China Solar, 1997. And nowadays, Sangro has reached the #1 supplier for finance projects, 100 bankable certified by Bloomberg NEF. And we have deployed more than 154 gigawatt inverters to the whole world. And in our global market share is more than 15%. This part, Sangro has launched the manufacturing bases in China and India to meet the global booming demand. In March of 2019, the world's largest inverter factory is ready to go. Furthermore, the global production capacity surpasses 90 gigawatts per year. Specifically speaking, the production capacity for China factory will be 80 gigawatt per year, and for our India factory, which is located in Bangalore, it has 10 gigawatt production per year. What's more, for our Sangro also has can offer the energy storage solutions, which the capacity of a lithium battery is 6 gigawatt hour per year, and for PCS is 6 gigawatts. And this part, I'm going to show the China Solar and Sangro solutions. First of all, it's for the small and medium CNI system solution. First of all, for the small size and medium size CNI system solution, which we made it inverter less than 10 pieces, we can support. We can offer the inverters from for the CX series, and we can also provide the wireless dongle. We call it IM4, which you can see from the middle of the picture, and for the monitoring platform, Sangro has offered the Solar Cloud web and app, which allows you to remote control the power plant remotely. The second part is for the large CNI system solution. We can offer more than over than 30 up to 30 pieces of inverter and controlled by one COM100E, which is our smart communication box, can be connected with Solar Cloud wirelessly or using RS485 standard cable. For residential PV system solution, Sangro has inverter and Wi-Fi dongle, and which also is compatible with Vertex S Modules. Besides this, Sungrow can offer the PV and ESS, which is called the hybrid inverter. You can see from the picture, not only the PV modules, but batteries DC coupled with the inverter itself. And for the AC side, Sungrow hybrid inverter could be connected with on-grid load and emergency load, which stands for the off-grid system. And the transition time for the on-grid to off-grid is less than 20 milliseconds. And this part is about the Sungrow products. For CNI inverters, Sungrow could offer the 33 kilowatt, 40 kilowatt, 50 kilowatt, and the biggest one is 110 kilowatt. And for the residential PV three-phase inverter, Sungrow could offer 5, 6, 7, 8, 10, 12, 15, and 17, 20 kilowatts. All the new three-phase inverters are divided into two types, 5 kilowatt to 12 kilowatts and 15 to 20. The 5 to 12 inverter has no fan and is self-cooling. The 15 and 20 inverter has two fans added at the bottom of the inverter, which is the difference between the two types. All modules have two MPPTs, but with different inputs. And for residential hybrid inverters, Sungrow provides 5, 6, 8, 10 kilowatt inverter, which helps you to build an energy storage plant with batteries. Moreover, hybrid inverters is able to handle with grid outage solutions, ensure your house powered on by the energy of sunlight. And Sungrow, this is the monitoring family of Sungrow. Wi-Fi and IM4 takes single and multiple wireless dongles. Smart communication both called COM100E as a data logger and iSolar Cloud as online monitoring system. And talking about the customer value, we are fully compliant with China Solar Vertex S Modules. As first of all, for the inverters compatibility, today I listed in this presentation is fully compliant with Vertex of S series. For the maximum input current of Sungrow inverters, we can support them up to 13 amperes from the DC side. And for talking about the short circuit current per string, we are able to handle more than up to 20 amperes per string, and this is the values of Vertex S modules are within the range of our inverter. And maximum modules per string, we can allow you to use up to 24 strings. For the DC configuration, Sungrow inverter is very flexible. For the maximum PV input voltage, open circuit voltage is 1,100 volts. That allows you to collect up to 24 pieces voltage per string. This is different from the 1,000 voltage inverter manufacturers. So another aspect is that for the CX inverters, we can support you to configure the power plant by a higher DC-AC ratio up to 1.5. By the help of multi-MPPT design, Sungrow has our patent algorithm and accurate tracking. For the smaller one, for 110 kilowatt inverter, we have 9 MPPT. For the smaller ones, 5 for 50, 4 for 40, and 3 for 33 kilowatts. For the residential, we have both. All of them have 2 MPPT inputs. Talking about safe and reliability. Sungrow has a ultra low radiation. we got a world-class EMC test lab located in our headquarters, and we have all of our products have much lower EMC test results than the IEC standards. And another function is we got arc fault detection, which are integrated all of our inverters, which helped you to resist from hazards of any potential risk. For the lightning protection, we got built-in surge arresters for both for DC side and AC side. For the we got optional for the CX inverter is type 2 1+2 SPD, which can handle higher lightning current up to 40 kA. For the design of the inverter, we got die-cast aluminum alloy casting for all the platforms. ID66 protection design is sealed with high anti-corrosion rating at C5. So that, in other words, all of our inverters could be installed both indoor and outdoor. And this is another interesting aspect for CX inverters. We could support you to install it horizontally by we got a special designed rack which are located under the inverter. So that helps you to save the space from the rooftop projects and completely a set of accessories we can offer. For the commissioning, you can finish the installation and commissioning via our Isolar Cloud app. It is touch-free commissioning with a smartphone. We got no LCD on the inverter itself, and one-click access to Isolar Cloud. You can realize remote OM and firmware updation. And the last aspect we got talking about our reference. This is a rooftop project using our SG110 CX series, which is located in Munich. This is taken by myself. It's located in near a shopping mall, and it realized self-consumption application with third-party loggers. And here's a project using our 110 CS with COM100 and Isolar Cloud. This is on a commercial rooftop of located in Hefei, China. And near your location in Dubai, this is the last generation of our products, the SG60 KTL. It's 18 megawatts located by installation is by parallelly in MENA region. Okay, thank you all for this is all my presentation.
Thank you very much, Shield, for your presentation on the inverters. And if you can stop sharing your screen now, so I can give the floor to Ewan, that would be great. So.
Okay, thank you, Carlos.
Thank you. Ewan,
hi, thank you, guys. I don't have a presentation or slides. I was just going to talk to you about the rooftop solar PV market in the Middle East and Africa region. I'm going to talk to you about a few different areas. I'm going to talk to you about how the contract itself is typically pulled together. I'm going to talk to you about how these projects are funded, and then I'm going to talk to you about some of the challenges. And one of the main challenges in this region is around regulation, and why is there so little, I guess, at this point in time of rooftop solar PV in this region, and why is there not a lot more of that type of project here? So to talk about the MENA region as a whole, then predominantly it's a utility scale clean energy program in this region. If we're talking at general levels, that means that it's utility scale ground-based solar. There is some utility scale wind as well, but in this region because of the geographical location and the fact that it's extremely hot. You have a lot of availability of land, which is suitable for large-scale utility-scale programs. So we have some of the largest ground-based solar PV projects in the world in this region. If I then turn to the actual rooftop solar contract itself, I'll just run through quickly how that's typically structured. It's typically a lease model. You'll have a supplier and owner of the kit who will supply that module, the solar PV module, to the person that resides in the property. The person that resides in the property will then typically get the benefit of the solar electricity generated, and they will be able to use that electricity in the property. And in exchange, they pay a lease payment to the person that has supplied that kit to their property. So this lease arrangement or solar rooftop lease arrangement will be in place for typically around 25 years. And the supplier of the kit will have the duty to install that solar PV onto the rooftop. And typically they will then have the obligation to maintain the service and maintain the quality of that solar PV on the rooftop for the duration of the term of the solar lease. In exchange, they get this monthly lease payment, and then the person in the property gets the benefit of the electricity generated from the solar PV for the duration of the contract itself. There are lots of provisions in this solar lease document, which can be anything from 20 pages to 40 pages, covers the obligations on both parties, the obligation of the person that owns the property or is in occupation of the property to make sure that the property is suitable for the solar PV on the roof, to allow the person responsible for installing and maintaining the solar to have access to clean and maintain the product. There are obligations around consents and the fact that the person in the property needs to make sure that they get any consent of any mortgage provider, that the insurance is in place to cover any damage to the product itself or damage to any third party. There are obligations on the installer of the kit to react in due course and to maintain the kit up to a certain specified standard. There is also guarantees in some contracts from the provider of the solar PV kit that the equipment needs to perform to a certain level. And then if it doesn't, there's typically a mechanism in the contract to allow the person in the property to benefit if the guarantee provided falls below a certain level. Depending on where in the region the rooftop solar project is based, so for example, if it's in the UAE, there is often an ability to export any electricity that's not needed by the person in the property to the grid. And the regulator in that particular jurisdiction will sometimes accept the electricity generated that's not needed, the excess capacity that's not needed by the person that owns that property. They can put the excess capacity back into the grid. How that typically works, though, is the regulators in the jurisdictions don't typically want people who are putting solar PV on their roof to become generators of electricity. So they will typically only allow people to put enough solar PV on their roofs that equates to the amount of power that the people have used in the historical 1 or 2 years before that, so that they are only putting on enough electricity for their own needs. But if there is an excess, they will allow the excess to be exported to the grid itself. One of the other issues faced is around payment guarantees. So how does the supplier of the PV kit, or the person that's installing and then expecting the payment for a 25-year period, what security do they have that that payment will be made? So there are a number of security measures that you typically see in a solar PV lease for rooftop projects. A parent company guarantee if the actual tenant or the person in the property is a company. You could have checks, letters of credit, on-demand bonds. Those are the type of security that a well-structured contract would set out. And then obviously if that security is only for a 1-year period, you'd have a rolling renewal of that security for the duration of the term of the contract itself. So those are some of the key issues with regard to the contract. I guess just finally, I would say that at the end of the term of the contract, there's sometimes a right to buy at the end of the term. So the owner or the supplier of the kit will give the tenant or the person that's received the benefit of this electricity the right to buy that solar PV at the end of the term. And then it's up to them if they want to buy it or not. And there's normally a formula in the contract itself to determine the actual price to buy that piece of kit. I think then, so that's a high level summary of a solar PV lease model that we see in this region. I think from a funding perspective, there are two areas to look at it from a funding perspective. From the perspective of the supplier of the, or the installer and supplier of the solar PV, then what they're looking for is scale. So they'll either have one large commercial customer who wants a lot of solar PV put on their roofs. And if you have that scale, then the supplier and installer of the solar PV can go out to the debt market and say, right, I've got this product. This is the counterparty. This is the credit rating of that counterparty. And can we now bring in debt finance to fund this installation cost? I guess on smaller projects, if you're looking at residential rooftop projects, you'd need scale. And what we've seen in other markets, you need scale of residential rooftops to be able to attract debt funding. You'd aggregate a lot of that. So if you were doing, for example, in the UAE, a large project with a new developer, new housing developer like EMA or any of the others building large new complexes, you could try and do a contract with that developer to try and put solar PV on all of the suitable properties in a particular area. You could then try and bring in debt financing by way of project financing or some kind of bond on that particular project. I guess from a funding perspective of the person in the property, you know, that in a way is easier because why they're doing it is the incentive for them is to fix their electricity price for a 25-year period. So in exchange for paying the DWA price, which may fluctuate, what they're trying to achieve is getting a agreed amount of electricity from the solar rooftop device itself, and therefore by implication they don't really need to have a funding model behind them because they would have been paying for the electricity to the utility provider in that jurisdiction. All they're doing now is paying a monthly lease payment and getting the free electric. So the funding's only really applicable on the supplier side unless you have an extremely large project for rooftop solar where the person that's going to be paying their monthly lease payments, they may look for some funding solutions. Just briefly then, to finish, I'll talk about the challenges. So why is there not a lot more rooftop solar in this region, in the Middle East and North Africa region? There are a number of reasons for this. One is the fact that a lot of the electricity in this region is subsidized. So going back over the last 3, 4, 5 years, there have been reasons why the subsidy has not been removed or why there still remains a subsidies. Some of the jurisdictions have had pressure on them not to do that because of the what's been happening in their specific jurisdictions. We then, so, you know, the economy hasn't been doing very well, for example. There's some unrest in that jurisdiction and that jurisdiction wants to keep the economy going. So they are not in a position to get rid or reduce the amount of discount they give on the electricity. We've then come into COVID. And jurisdictions haven't been looking to increase effectively the price of electricity for their large energy users. It's not been appropriate to do that. So the subsidies remained in place. If the subsidy remains in place, it doesn't make it economically viable, even with the price of solar PV coming down. It doesn't necessarily make it that obvious as to why people should invest time and effort and money to understand how rooftop solar PV will work and what benefits there are for them. You know, with the heavily discounted electricity price, there are more important things for a finance director or financial controller in a large corporate organization to focus on. But I still think the product works, and I still think if you have objectively look at the idea of rooftop solar, for me, it's definitely the way forward. There's a huge market for it and a huge opportunity. I think there was a recent study done in Riyadh in Saudi Arabia, and I think the scale of that market alone could be 400 megawatts of rooftop solar, theoretically, in a market just like Riyadh. So the scale is definitely there if it's done properly. One of the other challenges for rooftop solar is the wheeling regulations, or the lack of wheeling regulations. So if you have excess power, what can I do with that? Can I put it back into the grid? Can I sell it to somebody else? So can I sell it? Can I produce it here and sell it to somebody that wants to buy it in another part of the jurisdiction? To do that, you need the wheeling regulations. That's missing. It was in Jordan. There's been expectation that people have been waiting for those regulations. In other jurisdictions, it hasn't been forthcoming yet. But if there was wheeling regulations, it would allow people that are investing in putting rooftop solar on their roofs to then wheel power, or wheel the excess power at least, to other parts of that specific jurisdiction. Some of the challenges that are more specific. So in Africa, a lot of the African continent is not connected to the grid. So if you're going to do rooftop solar in lots of Africa, it needs to be on a basis that you can't wheel the power, because there's no ability to wheel the power. So you're only putting it in a very localized solution. That detracts from some of the larger scale rooftop projects, because there'll be no one to sell any excess power to. There's credit-worthy risk in some parts of Africa. If you're investing on a 20 or 25-year period, you'll need to be careful about who's going to be paying you the monthly lease payment, and you need to be careful around the security that you're going to get for that payment. And then I guess there are some, in some jurisdictions, for example, Dubai is probably a good example. You know, in some parts of the world, you have planning regulations that restrict the ability of people to build next door and build over your land, and you have a right to light. Whereas in some jurisdictions, those regulations aren't quite as sophisticated, which means that I guess in some locations, you may have some risks around, if you invest all this money, do you have the right to light for 25 years on that specific area? So that's all I had. It's just over the 10 minutes. I haven't been able to look at the questions, so I'll do that now and see if there's any specific legal questions for me to look at.
Thank you very much, Ewan, for your presentation. I think, well, you know, you have been very active, all of you, in answering questions. So I think we still have a few here, which many of which I think are very specific to the particular projects, you know, that the person asking the question is looking at. But I think, you know, at least from a technical point of view, there have been a few people asking the same questions, and even though, you know, you have answered them in writing, it might be good to talk about these issues. And one of them is regarding inverters, and they're talking about whether inverters are how are they cooled? Are they cooled naturally? Do they have inbuilt fans? So Shil, this is your area, so can you talk a little bit about this? Okay, Shil, can you hear me?
Okay, sorry, I was
That's
doing
okay.
typing. Yeah. For the fans integrated lower than 12 kilowatts, we adopt the natural cooling, which means there's no fan inside the inverter. And for the bigger ones, 15, 20, 33, 40, 50, 110, the smart air cooling, smart fan air cooling is adopted.
Okay, thank you very much.
Mm-hmm.
And also, I think this is a question that for the EAT, there have been also a few questions regarding the difference between the kind of modules and the equipment that you use for a ground mounted project and those that you use on rooftop. Is there any difference? Are they is there a specialized equipment for a rooftop environment?
Yeah, actually, the selection of the module itself is just being based on the project size and the area which do you have. Which this is actually the same mistake which is everyone just come in the market for it, because as you know, the trend now in the PV industry, it's going higher and higher and higher. We reached the 660 now, 670 watt for single module. So the selection when it comes from the EPC or it comes from the end user, everybody wants to go higher, higher, higher without considering that the area which he's installing, kind of inverter which he's gonna put these panels on it, number of cables, the structure, and handlation, and all these things. Well, yeah, when we can say that when you are going higher in the module, when you go into the ultra power 600 and plus, you are achieving, yes, better levelized cost of energy on the generation itself. But you actually neglected the big part, which is the POS saving, which is the system components which you have from the racks, from the mounting, from the transportation, and which kind of inverter which it can carry. This one, is your string big enough to carry on a bigger inverter of a high short circuit higher, or you will need to get a higher inverter in higher power which you don't need it. So actually it's always an equation from the POS saving and the levelized cost of energy. So that's why we are always saying that when you come to us with the size of a project, we can guide you. We can give you the free consultation. What will be the best module for the rest of the system components, which you have inverters, cable, and mounting structure? What will be the good one to have it? That's why we did it as a Terina, that we tried to complete our portfolio. We have the 380, 370, 400 watt, then 450 watt, 460, then we jump to 500, then 500. So every single family of these families with their different power pins, it depends on the application which you are using, which kind of inverter, cables, the area which you have, the generation, the yield, the country you are installing. So it's all about complete equation. So we can give you the perspective which one it can be fed and which one it can be used for your project.
Okay, thank you very much. That's very interesting. So it's not always, I suppose it'd be quite intuitively, people might think, well, if I have a higher power module, then I save space, so I should always go higher, but that's not always the case, because you
in this case we need to obsolete everything, come smaller. Like if it's always the equation about getting the higher module, so now we are 660, 670, so we should escape whatever behind 540, 500, 450. But why every company is trying to keep the full portfolio? Because the different kind of project, we have residential, we have CNI in 3 levels. Like we have a small CNI, we have a bigger rooftops, and we have a larger CNI. CNI can reach up to 5 mega. So there is a big CNI, big rooftops, and we have like a school, a huge rooftop with a small area for ground mounted. We can consider it CNI still. So it depends which level of project, which size you have. So based on that, you can do the selection.
Okay, that's interesting. And there is an interesting question here. And it says that the energy demand density in GCC is high since we use air conditioning heavily in summer. How would you justify the use of solar PV rooftops based on partial utility and high cleaning requirements? So I think, you know, this speaks to something I think many people have in mind, which is the operations and maintenance of rooftop PV. So you know, how do you optimize it, and is it really do you really have high cleaning requirements for a rooftop PV in the GCC area?
It's the standard cleaning, you know, that's when we are talking about the GCC area, you know, the modules, like let's talk about the module, the module manufacturer and everything. That's the guy who is already here, and they are specialized a little bit in our industry. That we know that we have a climate code. So each zone, like I'm asking every customer which country of installation you have, because it's having different EVA, it's having different backsheet, it's having different KBA. So this is, every module can be, like the module which can be supplied for area which is high in ammonia next to the coastal is different from the one will be in the middle of the desert, different from the one will be in Russia somewhere for a snowing area, or the Europe one. So the manufacturing of the module itself, it considers the climate which the module is going to be. So talking about the GCC area, our main challenge in GCC area is not the cleaning, it's the heat. So the temperature, the higher temperature which comes on the module itself, this is the problem. But the cleaning, the standard cleaning can be easily for any module, because the module at the end, it's high and it's like, we can say, it's an industrial item. It's a heavy use, you know. It had been made to be put on a rooftops or in a ground mounted for a 25, 30 years, 40 years. So it's actually a heavy duty item, and the standard cleaning, if they are following our manuals, they can be satisfied just to do. There is no need for a complicated cleaning system for GCC area. You don't need it. Just the standard cleaning system can work.
Okay. Well, that's good to know. I think there are still quite a few questions, but we are just run out of time now. So, well, I'd like to remind everyone that we will send you the recording of the webinar and the slides, and there you may send questions that have been unanswered to our panelists. And well, like to thank all of you, the Eid, Shil-Shi, and Ewan Walters for being with us today. It's been very interesting, and I'd like to thank everyone who's also been listening to us and watching the presentations. So don't know if you have any parting words for the audience. Let's start with you, Dia.
Sorry, Carlos, I didn't hear you.
If you have any parting words, so just to say goodbye.
Thanks everybody for giving time today and for attending. It was really nice. The question which you had interacted with us, it was really fruitful to make the session full of information. I had shared my contact details and my office details as well. So if anybody's having extra question after we are closing, you are welcome to drop us an email and we will be happy to answer your question. And thanks, Carlos, for the time today. Thanks, Shishal, and thanks, Ivan. That was really nice to be with you today. Thank you so much.
Thank you. Anyone else? Any parting words? Ewan, I see you've got your microphone open.
I was just going to say, look, the opportunity is huge. We're not quite there yet on the rooftop solar in this part of the world. Other markets, Europe, America, are already there. And we're slowly getting there, especially in places like the UAE. It is going in the right direction. So yeah, with partners like this on this call, yeah, I'm sure we'll get there.
Thank you. Shield, please.
Thank you for Carlos and all of the attendants here today. Your questions are very meaningful to me, and we will optimize our products according to your requests. And we are here to waiting for your questions if you are interested in Sungrow. And you can write email to me and I will be able to answer. Thank you for all of you.
Well, thank you very much to all of you, and yeah, see you here next time.